This video quickly summarizes stability. And the reason we want to understand stability as pilots is because the greater the stability, the less maneuverable the airplane. However, the controllability of the airplane is better. And the opposite is true as well. If the stability is low, the maneuverability is high, and the controllability is low. Think about it as a jet fighter being able to do a quick barrel roll. Well, that jet fighter, even though it can do a quick barrel roll and it's highly maneuverable, needs a lot of computers on board to control the airplane, because it's not very easy for pilots to control modern jet fighters. The first type of stability we need to be familiar with is static stability. And this is the initial tendency of the airplane or aircraft when the aircraft is deflected from steady flight. Positive static stability is the initial tendency the aircraft will have to come back to its previous steady flight. As an example, let's look at a bowl and a ball within that bowl. If we were to deflect this bowl and bring it up here, the initial tendency of this ball is to come back down, and it'll eventually settle right where it started. And it's this initial tendency to come back to its original position that is called positive static stability. Neutral static stability is the tendency for the deflection to stay where it is. So if we have a table and a ball on that table, if we deflect this ball and bring it over here, the initial tendency will be to stay exactly where it is. It won't come closer to its original position and it won't go further away. Finally, negative static stability is the initial tendency for the deflection to get worse. We'll place a ball on top of an upside down bowl and deflect it in this direction. And its initial tendency will be to go in this direction, not where it originally started. If we understand that, let's move on to dynamic stability, and this is the stability over time. And it depends on the initial tendency. There are 3 different types of dynamic stability, and they all depend on there being positive static stability. So let's draw a line and an airplane on that line, and it's flying in a steady state in this direction, and then we deflect it so that the nose comes up. Because of the positive static stability, it will want to come back down. It'll overshoot, which will make it want to come back up, and eventually these oscillations will even out, and the airplane will end up flying nearly in the same state that it was in before it was deflected. This is positive dynamic stability because over time these oscillations get smaller and smaller and end up right where they began. Neutral dynamic stability is similar, however the oscillations don't get better. Because they're neutral, they stay the same. We have our aircraft in a steady state, we deflect it upward, and it begins oscillating, and it will never cease. Negative dynamic stability, and you're probably catching on here, will deflect the aircraft, and these oscillations will get worse and worse. Most all of the trainer airplanes that we'll be flying to get our private pilot certificate display positive dynamic stability. Now you may be wondering, what does neutral static stability look like over time? So to look at that, we'll draw this line and we'll deflect the airplane up this way. Because it stays in the same place, it looks like this. And finally we can take a look at negative static stability over time. And we can see that if we displace the aircraft upward, it will want to get worse. So it'll eventually do something like that.